students, welcome again into the 12th science chemistry class. Last few lectures we are learning the chapter number 3, Ionic equilibrium, and in the last lecture we learned the pH, definition of pH and pOH, that is the pH scale or Sorensen scale, and in that we define the pH as the negative logarithm to the base 10 of H plus ion concentration. As the H plus ion and H3O plus ions are same, so it is considered as the same. H plus ion is equal to H3O plus ion. Now today again we define the pOH as, that is the negative logarithm to the base 10 of OH minus ion concentration, that is the hydroxyl ion concentration. Now today we are going to learn a very important relationship always asked in examination for 2 to 3 marks. So a relationship between pH and pOH. The ionic product of water. Now this relationship we prove by taking the ionic product of water. That is the formula of ionic product of water, that is the Kw. So the ionic product of water Kw is given as Kw is equal to H3O plus ion concentration into OH minus ion concentration. Now we can take here H plus ion concentration, that is also correct. Now Kw, we know that value of the Kw in the last lecture. We calculate that value of Kw as 1 into 10 raised to minus 14 at room temperature, that is 298 Kelvin or 25 degree centigrade. And how this value comes? Because we know that in the pure water, the both types of ions concentration are similar, and that is nearly equal to 1 into 10 raised to minus 7 mole per decimeter cube, because water is very less ionized. I already told this in the last lecture. So 1 into 10 raised to minus 7 multiply by 1 into 10 raised to minus 7 becomes 1 into 10 raised to minus 14. So the value of Kw, that is the ionic product of water, is equal to 1 into 10 raised to minus 14 at 298 Kelvin. Now this H3O plus ion concentration and OH minus ion concentration is equal to 1 into 10 raised to minus 40. From these two equations, Kw, left hand sides are equal, therefore right hand sides are also equal, and therefore H3O plus ion concentration into OH minus ion concentration is equal to 1.0 into 10 raised to minus 14. Now taking negative logarithm to both sides, we have to prove pH plus pOH is equal to 14. For that, take the negative logarithm to both sides of this equation. Now we know that in logarithm, the multiplication means summation. Now here we are taking the negative logarithm, so it becomes minus log to the base 10 of this H3O plus ion. As we are taking, if we take only the logarithm, here will be the plus sign. But we are taking negative logarithm, so it becomes minus log to the base 10 of H3O plus minus log to the base of OH minus is equal to, now here also, that is the, we have to multiply by minus, therefore minus log, negative log of 1.0 into 10 raised to minus 14. Up to this, you understand, students? This is very important step. Only take the negative logarithm of all these in this equation. So on taking the negative logarithm, we will get this type of the values. Now we know that the negative logarithm to the base 10 of this H3O plus ion, that is the H plus ion, what is that? That is equal to pH. And what is the negative logarithm to the base 10 of OH minus ion? That is equal to pOH. So this negative logarithm is equal to pH plus this negative logarithm is equal to pH. Remember that here now plus sign, because the value of all this term, that is the negative logarithm to the base 10 of OH minus is pOH, and the value of all with this negative sign, definition of pH and pOH. They are the negative logarithm to the base 10 of H plus ion concentration and OH minus ion concentration respectively. Now how this will solve? Now pay attention, this is very important. Now here is the log of 1.0 means log of 1. If you see the log of 1, that means log of 10, there the value is 0.0000. But we have to take only log of 1, so the characteristics also becomes here 0. Log of 10 have characteristic 1, we know that. But here only log of 1, so the characteristic is 0 and the value of, that is the log 10 is 0.0000. Because we have to see the log 10, there is starting of log from 10. But here we have to see the log of 1. So the characteristic becomes here 0. And this minus sign is for this bracket. All these terms in the bracket, therefore minus 0.0000. Now this minus 14, which is the power, gets multiplied as minus 14 and again minus log of this 10. Minus log of 10 is 0.0000. But 10, so the characteristic is 1. But here is the minus log, so here sign is also minus. Remember that. Now this minus 14 into this minus 1, because there is the bracket between these two. So there is the multiplication. So minus 14 into minus 1 is equal to plus 14. And this minus 0.00 as it is. But if we subtract this minus quantity, that is minus 0 from this 14, it remains as 14. So what will be the value? pH plus pOH is equal to 14. Now this is the relationship between the pH and pOH. Remember students, this is the relationship. pH plus pOH is equal to what? 14. Now this is very important equation. Remember that in the solutions always pH plus pOH is equal to 14. Remember that. Suppose the pH of the solution is 10. Then what will be the pOH? How we calculate that? So if we calculate that of the pOH, then only just write down pOH is equal to 14 minus pH. If the pH is 8 or 10, suppose pH is 10, then pOH is 4. That means the summation of pH and pOH is always 14. And if we have to calculate, suppose pH is given, and if we have to calculate the pOH, then just subtract pH from the 14, because pOH is equal to 14 minus pH. And here I given again minus log to the base 10 of H3O plus, that is the H plus ion is equal to pH, and minus log to the base of 10 of OH minus ion concentration is equal to pOH. Now let us learn very important topic again, acidity, basicity and neutrality of aqueous solutions. How we can predict that the solution is acidic, basic or neutral, that we have to study by using these pH and pOH values. Now first learn about the neutral solution. Now we know that the neutral solution, that is the pure water is the neutral solution. Again there are so many neutral solutions, and we always speak that the pH of the neutral solutions are 7. Now how it is 7? Let us learn. For pure water or any aqueous neutral solution, for pure water or any aqueous neutral solution, at 298 Kelvin, that is at room temperature, always these two ion concentrations are equal. We know that, that is the H3O plus is equal to OH minus, and we know that the value of these ions is equal to 1.0 into 10 raised to minus 7 molar. Both have the same value, 1.0 into 10 raised to minus 7 molar. So concentration of H2O plus is equal to concentration of OH minus is equal to 1.0 into 10 raised to minus 7 molar. Now here we know that as the concentration of both ions are same, so their pH and pOH values are also same. Now pH is equal to minus log to the base 10 of H plus ion. Now what is the value of H plus ion concentration? It is equal to minus log to the base 10 of 1.0 into 10 raised to minus 7. As we calculated here, that is the value of this 1.0 into 10 raised to minus 14, the value of pH of 1.0 into 10 raised to minus 14. In the similar way, we calculate the value of 1.0 into 10 raised to minus 7. Now how it is calculated? Therefore pH is equal to, now this minus log of 1, minus log of 1 is minus 0.001. I told you that, because see the log of 10 and the characteristic here is 0 because only one digit 1. Therefore we always take 1 minus 1 characteristic, that is therefore 1 minus 1 becomes 0, and as there is the negative side, so give here negative side. Again this minus 7, which is the power, comes here minus 7 multiplied by minus log of 10. What is the log of 10? Log of 10 is 0.000. That means if we see the log, that is the 0.00. But as there is the 10, 2 digits, so the characteristic becomes 1. Therefore here I write as minus 0.000 minus 7 into bracket minus 1.000. Now minus 7 into minus 1 becomes plus 7, and therefore this pH is equal to 7. From plus 7, if we subtract the minus 0, it becomes only the 7. So minus 7 into minus 1 is equal to plus 7. So the neutral solution have the pH 7. In this way we obtain the value of pH for the neutral solution as 7. Therefore for neutral solution, pH of the solution is always 7. How it is calculated? Let's learn again. Now in this way it is calculated. The pH is equal to minus 0.000 minus 7 into minus 1. Minus 7 into minus 1 become plus 7, and therefore the pH of the neutral solution is plus 7. Now let us see the pH of the acidic solution. Again pay attention students on the blackboard. Now we calculated already the pH of the neutral solution. Now let us calculate the pH of acidic solution. How we can determine or detect the pH of acidic solution? Now in acidic solution we know that there is definitely excess of H3O plus ions, that means H plus ions are more in acidic solution. So as H plus ions are more, therefore their concentration is also more than 10 raised to minus 7. That means the values such as which are the values for H plus ion concentration in the acidic solution? From 1.0 into 10 raised to minus 1 to 1.0 into 10 raised to minus 6. Because we know that the 1.0 into 10 raised to minus 7 is the value of H plus ions in the neutral solution. But we have to calculate here the that is the pH of the acidic solution. So the concentration of H plus ion is more than the value of 1 into 10 raised to minus 7. And which are the more value than the 10 raised to minus 7? That is such as 10 raised to minus 6, 10 raised to minus 5, 10 raised to minus 4, minus 3. These are the less value. But if 10 raised to minus 8, these are the more value. 10 raised to minus 6, 10 raised to minus 5, 10 raised to minus 4. These are more value than 10 raised to minus 7. And which are the less value? 10 raised to minus 8, 10 raised to minus 9. They are the less value. Remember that. So, as the H plus ion concentration is more than the OH plus ion concentration is always greater than 1 into 10 raised to minus 7. And how that value? 1.0 into 10 raised to minus 1 to 1.0 into 10 raised to minus 6. So definitely, as the concentration of H plus ion is more, having such value, so the pH is definitely from 1 to 6. From 1 to 6, and which is less than 7, and therefore definitely the pH is always less than 7 for the acidic solution. And how that pH? From 1 to 6 or 6.9. That the solution having the pH from 1 to 6.9 are acidic in nature, and the solution having the pH 7 is basic in nature, and the solution which have the pH more than 7 such as 8, 9, 10 up to 14, the solutions are basic in nature. Remember students. Now let us take one example of acidic solution, how we can calculate the pH. For example, if the H3O plus ion, that are the H plus ion, similar, having the concentration 1 into 10 raised to minus 5 molar, then calculate the pH of the solution. How it is calculated? Now pH is equal to minus log to the base 10 of H3O plus ion. Now this is the formula of the pH. What is? pH is equal to minus log to the base 10 of H3O plus ion. Now substitute the value of this H3O plus ion as 1 into 10 raised to minus 5 molar. So minus log to the base 10 of the value of this H3O plus ion, substitute here 1 into 10 raised to minus 5. Now calculate this. How it is calculated? Let us see on the blackboard. Now see here, therefore the pH is equal to, now this minus log of 1. So I write here minus log of 1 into 10 raised to minus 5 means this minus 5 take here, that is the power, and into, now this minus log is for both this 1 and this 10 also, so into minus log of 10. Now the value of log of 1 is 0.0000 as characteristic is 0, but as there is minus sign due here, but 0 does not have plus or minus sign, so it is 0 only. Now this minus 5 is as it is, and what is the log of 10? Log of 10 is 1.000 because characteristic is 1, but as here is the negative sign, so write down here minus 1.000. Now this minus 5 and minus 1, if we multiply that, minus 5 into minus 1, that becomes plus 1, and this 0 is as it is, but it does not have any value, so the pH of the solution is 5. As pH is less than 7, definitely the solution is acidic in nature, and therefore the solution is acidic in nature. In this way we can determine the nature of the solution by calculating the pH of the solution. Now let us learn the third point, that is the pH of basic solution. How we can determine the pH of the basic solution. Now in basic solution, the excess of OH minus ions are there, definitely as the solution is basic, there are excess or more OH minus ion, because in the acidic solution there are excess or more H plus ions, so in the basic solution there are excess or more OH minus ions are present. Therefore the concentration of this OH minus ion is always greater than this H3O plus ion in the basic solution. We know that, and more than the more values of the OH minus ions mean how these less H3O plus ions are having the less value than the OH minus ion. Less value than OH minus ion means if the concentration of OH minus ions is 10 raised to minus 8, minus 9, then what will be the value of concentration of this H3O plus ion? That is the value of OH minus ions is greater, that is the greater than 10 raised to minus 7. How it is that 10 raised to minus 6, 10 raised to minus 5, which value? This OH minus. Then what will be the value of H3O plus ion, which is less than 10 raised to minus 7? Then how that value? That value are from 1 0.1, 0.0 into 10 raised to minus 8 to 1.0 into 10 raised to minus 14 molar, because these are the less values than the 10 raised to minus 7. So the concentration of H3O plus ion is in between these values, 1.-8 to 1.-14, which are the less value, less than 7. So the less value of H3O plus, the value concentration of H3O plus is always less than 1.0 into 10 raised to minus 7, and that is in between that. And definitely the pH, if the values are in this way, the pH are from 8 to 14, and which is greater than 7. Therefore, definitely pH is greater than 7, because the values are from minus 8 to minus 14. If we calculate this value of pH of this concentration, it comes from 8 to 14, and which is greater than 7. Therefore, the pH of the basic solution is always greater than 7. Remember that. In this way, students, we can determine the acidity, basicity and neutrality of the solution. If you like this video, if you have understand this video, then you like, subscribe and share this video to the other students, so that they also can get the benefit. And this is very, very important topic. Thank you for watching this video. You can take the screenshot and write down the notes which are very, very important. The pH of acidic solution and basic solution are calculated in this way. So remember, pH of neutral solution is always equal to 7. pH of acidic solution is in between 1 to 6.9, and pH of basic solutions are from 7.1 to 14. So this is about the pH and pOH. We will draw the pH scale into the next lecture. Thank you again. Write down notes.